In this video, we'll learn how to factor quadratic polynomials, which are polynomials of degree 2. We'll be looking at factoring in two situations. In the first situation, the quadratic has leading coefficient 1, and in the second situation, the leading coefficient is not 1, and that makes things a little bit more tricky. So let's start with the easier version. So we want to factor polynomials of the form x squared plus bx plus c, where b and c here are constant real numbers. Quadratic polynomials of this form can be factored as x plus some number times x plus some other number. From what I have written down there, I have it written as x plus the Greek letter alpha times x plus the Greek letter beta. So our goal when factoring these quadratics is to figure out what value alpha and beta are. To give us an idea of what alpha and beta need to be, let's multiply out the expression x plus alpha times x plus beta. To multiply x plus alpha times x plus beta, we'll be using the FOIL method. F stands for the first terms, so multiplying the first terms of the two binomials together, we get x squared. The O stands for the outer terms. The outer terms here are the x and the beta. Multiplying that together, we get beta times x. The I stands for the inner terms. The inner terms here are alpha and x. So multiplying those together, we get alpha times x. And then the last terms are alpha and beta. So we add to this alpha times beta. If we combine the like terms beta x and alpha x, we end up with x squared plus alpha plus beta times x, and then plus alpha times beta. Now remember that we want x plus alpha times x plus beta to be a factorization of x squared plus bx plus c. So those two things should be equal to each other. Now when we multiplied out x plus alpha times x plus beta, we got the expression x squared plus alpha plus beta times x plus alpha times beta. Now this quadratic should equal x squared plus bx plus c, which means their coefficients should match, meaning the coefficient in front of the x here, the b here, should be the same as the coefficient alpha plus beta. Also, the number at the end, c here, should be the same as the number alpha times beta. So again, this tells us that alpha plus beta is equal to b, and alpha times beta is equal to c. So if we want to factor the quadratic polynomial x squared plus bx plus c, we need to find two numbers, which we called alpha and beta, that add up to b and multiply to c. Let's work through some examples. In our first example here, we have the polynomial x squared plus 8x plus 15. So in this example, the b is the coefficient of x, which is 8, and c is the number added at the end, which is 15. So to factor this quadratic, we need to find two numbers that add up to 8 and multiply to 15. One approach is to come up with pairs of numbers that multiply to 15. For example, 1 times 15 gives us 15, and also 3 times 5 gives us 15. Now, of those pairs of numbers, do any of them add up to 8? So here, looking at 1 and 15, I see that 1 plus 15 is equal to 16, which does not add up to 8. However, if I look at the pair 3 and 5, 3 plus 5 is equal to 8. So that's what we want. So the pair of numbers that add up to 8 and multiply to 15 is 3 and 5. So the way we factor x squared plus 8x plus 15 would be to write this as x plus 3 times x plus 5. So that's how we factor this quadratic. We can check that this factorization is correct by doing the multiplication and seeing if it matches up with x squared plus 8x plus 15. So if I take x plus 3 and multiply it to x plus 5, well, using the FOIL method, the first terms multiplied together would be x squared. The outer terms are x and 5, so their product is 5x. The inner terms are 3 and x, so their product is 3x, and then the last terms are 3 and 5, and their product is 15. Combining the like terms 5x and 3x, we get that this is x squared plus 8x plus 15. So this does match up with what we started with. Let's look at some more examples. So in our next example here, we want to factor x squared plus 3x minus 10. For this quadratic, b is 3 and c is negative 10. So if we want to factor this quadratic, we need to come up with two numbers that add up to 3 and multiply to negative 10. We'll start by coming up with pairs of numbers that multiply to negative 10. For example, negative 1 times 10 gives me negative 10. And also, 1 times negative 10 gives me negative 10. We can also do negative 2 times 5. That'll give us negative 10. And we can also do 2 times negative 5. That also gives us negative 10. Now, of these pairs of numbers, do any of them add up to 3? For example, in our first pair, negative 1 and 10, negative 1 plus 10 gives us 9, which is not 3, so that's not the correct pair. Next, we have 1 and negative 10. 1 plus negative 10 gives us negative 9. Again, that's not equal to 3, so that's not the correct pair. Next, we have negative 2 and 5. Negative 2 plus 5 gives us positive 3. That's what we want. So the numbers are negative 2 and 5. So to factor x squared plus 3x minus 10, we write this as x plus negative 2, or x minus 2, and then times x plus 5. Again, if you want to check that this is the correct factorization, you can multiply out x minus 2 times x plus 5 and check that you get the original quadratic x squared plus 3x minus 10. In our next example, we want to factor the quadratic x squared minus 7x plus 12. In this problem, our b is negative 7 and our c is 12. So we want two numbers that add up to negative 7 and multiply to positive 12. So I want to start by thinking of pairs of numbers that multiply to 12. For example, 1 times 12 gives us 12, 2 times 6 gives us 12, and also 3 times 4 gives us 12. But notice that when I add any of those pairs of numbers, I'm always going to end up with a positive number. For example, 1 plus 12 is positive 13, 2 plus 6 is positive 8, and 3 plus 4 is positive 7. So we need to think of another way to multiply to 12 so that when I add up the two numbers, I get a negative number. To do this, I'm going to instead look at negative 1 times negative 12. Those multiplied together gives us positive 12. Instead of 2 times 6, I can do negative 2 times negative 6. Their product is positive 12. And then also negative 3 times negative 4 gives us positive 12. Now looking at these pairs of numbers, their sum is going to be a negative number. The sum of the first pair, negative 1 plus negative 12, gives us negative 13. But that's not equal to negative 7, so that's not the correct pair. The second pair, negative 2 plus negative 6, gives us negative 8. Again, that's not negative 7. The last pair, negative 3 plus negative 4, that is negative 7. So that's the pair that we want. So I can write x squared minus 7x plus 12 as x plus negative 3, or x minus 3, times x plus negative 4, or x minus 4. So that is the factorization for x squared minus 7x plus 12. Let's look at one last example. Let's say we want to factor the quadratic x squared minus 3x minus 4. So here, our b is negative 3, and our c is negative 4. So we need two numbers that add up to negative 3 and multiply to negative 4. Again, we'll start by coming up with pairs of numbers that multiply to negative 4. For example, we have negative 1 times 4, giving us negative 4. We can also do 1 times negative 4 to give us negative 4, and maybe 2 times negative 2, which is negative 4. Now, of these pairs, do any of them add up to negative 3? If I do negative 1 plus 4, that gives me positive 3, which is not negative 3, so that's not the correct pair. If I do 1 plus negative 4, that gives us negative 3, and that's what we want. So 1 and negative 4 is our correct pair. So our quadratic x squared minus 3x minus 4 factors as x plus 1 times x minus 4. Now, as you get more comfortable with this, you don't need to write out all of this work. You'll want to get to the point where you can do this in your head. You'll want to be able to come up with two numbers that add up to the coefficient b and multiply to c. So now let's look at the more complicated version, where the leading coefficient of our quadratic is not 1. To factor a quadratic polynomial of the form ax squared plus bx plus c, we'll need to follow a few steps. To factor the quadratic ax squared plus bx plus c, the first step is to come up with a pair of numbers, alpha and beta, that multiply to the product a times c and add up to b. In our next step, we'll rewrite ax squared plus bx plus c by substituting in alpha plus beta in for b. So then bx can be thought of as alpha x plus beta x. So our quadratic can be rewritten as ax squared plus alpha x plus beta x plus c. In our next step, we'll be grouping certain terms together. We'll look at ax squared plus alpha x on its own and beta x plus c on its own, and we're going to factor these separately. And then our final step is to pull out the common factor in both groups. Let's go through some examples to see how this procedure works. In our first example, we want to factor 3x squared plus 17x plus 10. Notice that this is different than our previous examples because we have this 3 in front of our x squared, which means we can't do what we had done before, and now we need to use this new procedure. So in this problem, our a is this 3 here, our b is 17, and c is 10. In our first step, we want to find a pair of numbers, alpha and beta, that multiply to a times c and add up to b. In this case, a times c is 3 times 10, or 30. So we want to find a pair of numbers that multiply to 30 and add up to 17. Notice that 2 times 15 gives us 30, and 2 plus 15 give us 17. So the pair of numbers that we want here are 2 and 15. That's going to be my alpha and beta. So we're done with step 1. In step 2, we want to take our polynomial ax squared plus bx plus c and rewrite it by replacing alpha plus beta in for b. So we're going to take our polynomial 3x squared plus 17x plus 10 and rewrite this middle term. The 17 we're going to replace with 2 plus 15. So here 17x can be broken down into 2x plus 15x. So we have 3x squared plus 2x plus 15x plus 10. In our next step, we're going to look at 3x squared plus 2x as one group and 15x plus 10 as a second group, and we're going to factor each of those groups separately. The 3x squared plus 2x has a common factor of x, so I can use the distributive property to pull that out. I can rewrite this as x times 3x plus 2. In our second group, 15x plus 10, I see that there's a common factor of 5 in both of those terms. So using the distributive property, I'll pull out the 5, and what's left is 3x plus 2. So that's step 3. In the last step, we want to pull out the common factor in both groups. Looking at the two groups, I see that I have a factor of 3x plus 2 here, and another factor of 3x plus 2 here. That factor of 3x plus 2 can be pulled out using the distributive property, so we can write this as 3x plus 2. From our first group, we have x remaining, and from our second group, we have 5 remaining. And that's it. So our polynomial 3x squared plus 17x plus 10 can be factored as 3x plus 2 times x plus 5. Again, to check that this is the correct factorization, we can take the product 3x plus 2 and x plus 5 and multiply this out. The result that we should get at the end is our original quadratic. So let's multiply this out using the FOIL method. The first terms are the 3x and the x, so their product is 3x squared. The outer terms are 3x and 5, so their product is 15x. The inner terms are the 2 and the x, so their product is 2x. And the last terms are 2 and 5, and their product is 10. Combining the like terms 15x and 2x, we end up with 3x squared plus 17x plus 10, which is our original quadratic. So we see here that we do indeed have the correct factorization. Let's look at a couple more examples. In this example, we want to factor negative 2x squared plus x plus 6. So here, a is negative 2, b is 1, and c is 6. In our first step, we want to find a pair of numbers that multiply to a times c and add up to b. So a times c in this case is negative 2 times 6, or negative 12. So we want two numbers that multiply to negative 12 and add up to 1. Notice that 4 times negative 3 give us negative 12, and 4 plus negative 3 give us positive 1. So the two numbers that we're interested in are 4 and negative 3. In step 2, we want to take our polynomial negative 2x squared plus x plus 6 and replace the b with alpha and beta, with our two numbers. So we're going to replace this x here with 4x minus 3x. So overall, our polynomial looks like negative 2x squared plus 4x minus 3x plus 6. In our third step, we're going to group the terms negative 2x squared plus 4x together and group the terms negative 3x plus 6 together, and factor each of those groups separately. Looking at our first group, negative 2x squared plus 4x, I notice that we have a common factor of 2 and x in both of those terms. So I can pull out a 2x. What's remaining after I pull out a 2x is negative x plus 2. In the second group, negative 3x plus 6, I notice that I have a common factor of 3 in both of those terms. So I can pull out a 3, and what's remaining is negative x plus 2. In our final step, we notice that there's a factor of negative x plus 2 in the first group, and also a factor of negative x plus 2 in our second group. So that can be factored out of both groups. So factoring out the negative x plus 2, what's remaining is 2x from the first group and plus 3 from the second group. So we see here that negative 2x squared plus x plus 6 factors as negative x plus 2 times 2x plus 3. Again, if you wanted to, you can check that this is the correct factorization by multiplying out negative x plus 2 times 2x plus 3. If you do that, you'll confirm that you get the polynomial negative 2x squared plus x plus 6. In our last example here, we want to factor the quadratic 6x squared minus 23x plus 7. So in this quadratic, our a is 6, our b is negative 23, and our c is 7. So we want two numbers that multiply to a times c and add up to b. A times c in this case is 6 times 7, or 42. So we want two numbers that multiply to 42 and add up to negative 23. Notice that negative 2 times negative 21 give us positive 42, and negative 2 plus negative 21 give us negative 23. So the two numbers, alpha and beta, that we'll use are negative 2 and negative 21. In step 2, we'll take our quadratic 6x squared minus 23x plus 7 and replace the negative 23 with negative 2 and negative 21. So negative 23x can be written as minus 2x minus 21x. So overall, our quadratic is 6x squared minus 2x minus 21x plus 7. In step 3, we'll split up our quadratic into two groups. We'll look at 6x squared minus 2x as one group and negative 21x plus 7 as my second group. If I factor the first group, 6x squared minus 2x, I notice that I have a common factor of 2x. So I pull that out, and what's remaining is 3x minus 1. In the second group, negative 21x plus 7, I notice that there's a common factor of 7. So if I pull out the 7, what's remaining is negative 3x plus 1. Now in our last step, we want to pull out any common factors in our two groups. Well, in our first group, we notice that we have a 3x minus 1 here. But we don't quite have that same factor in our second group. Instead, we have negative 3x plus 1. They're similar, but it's off by a factor of negative 1. So what we can do is think about the terms in our second group as negative 1 times 3 times x plus negative 1 times negative 1. Notice that if you multiply through, you get the same thing as above. When we write our expression this way, we notice that there's a common factor of negative 1 in the first term and a negative 1 in the second term. So using the distributive property, we can pull out the negative 1, and what's remaining is a 3x minus 1. So rewriting our entire expression, we have 2x times 3x minus 1 plus 7, and then the negative 3x plus 1 I can replace with negative 1 times 3x minus 1. Now our two groups have a common factor of 3x minus 1. So we can use the distributive property and rewrite this as 3x minus 1 times 2x that's left from our first group, and 7 times negative 1, or negative 7, in our second group. So we see here that 6x squared minus 23x plus 7 factors as 3x minus 1 times 2x minus 7. So that's it for this video. In our next video, we'll talk about factoring a difference of squares.